Hacky. It's a vision system. It's a vision system that can do traditional machine vision as well as AI-based machine vision and a combination of the two. So this is the controller that I'm showing right now. Give you an idea of the size. This controller can fit inside a control box. So your food grade, we would want to put it inside a food grade enclosure, or it can sit standalone if there's no special requirements environmentally. Yeah, go on imaging source. So this is just a picture of one of the industrial cameras we use. They're all industrial. They go from 2 megapixels up to 42 megapixels. This is an actual station. It's a GP12 station for a GM project where we show the cameras on the actual station. So there's 3 cameras on the station. 1 overhead looking at the center of these parts, and then 2 on the left and right side with special lighting because we're doing some very particular measurements on these parts. So I'm going to get into some applications. We started this with molding. Sorry, were you guys asking a question?
I'm sorry, I'm standing way far away. Yeah, where do you have these right now, or maybe what kind of application?
Yanfeng, USF, US Ferrithane,
Yep.
Cooper Standard.
With that Yank Bank, are they using it in the interior?
They're using it for door panel assembly.
Oh, maybe paint that. Okay, cool.
Yeah, so rather large companies. We have it actually in production. Cascade, CK is another one. So a number of companies, and we have a number of applications, which I'll try to go over somewhat quickly. So we started off with molding. The robot pulls the part out of the mold, or multiple parts, and presents it to the Camry. So the extruded aluminum that you see from the back is actually the robot. This is a 5 megapixel camera. We're doing object detection in this case, where we just section off the 4 sides of the part and verify that they score above a certain level. So this is purely AI-based object detection. So if I go to defect detection, it show you what we're actually detecting as a failure on that part. So you see this little tiny notch out of this part?
Yeah.
We're able to detect defects of that magnitude.
Nice.
And if you know anything about traditional machine vision, that's pretty much impossible to do.
Yeah.
Unless you have a camera just looking right in that area and you're doing some type of an intensity measurement, maybe, pixel count.
How many training cycles typically do you get that kind of repeatability on that?
This one probably trained on, I'd say, 20,000 images where it got to this point.
Okay.
So about 10 days worth of production.
Okay.
They run about 2,000 parts per day. So fairly quickly.
Yeah, that's not bad.
I mean, the nice thing about the AI stuff is that it gets smarter over time. So if you continue to train the system, it just gets better and better as time goes on. So there's a lot of images in here. You guys can point me to the one you want to have more information about. I'm going to kind of just go over all of them. We use it for parts presence. So this is, we're really in automotive, though I'm going to show you some outside the automotive. But this automotive SUV grill, where we're sensing the presence of screws, very small clips, spring clips that are holding assemblies together, brackets, bug screens. So lots of just parts of assembly. This is a multi-layer process, so we run the cameras sometimes in what we call step mode, where we'll check things at one layer of assembly. Then they put on another layer, assemble, and we run another step that checks for different things. And so it's a multi-step process, if that's how you configure it. Chrome grills, bumpers is another one. So this is a semi-bumper. One of the things you'll notice in these images is that There's no special lighting, so you're seeing a big glare from the environmental lighting overhead. It's fluorescent lighting in a big plant. Our system is not that sensitive to lighting. Whereas, traditional machine vision systems really have to have the right lighting. So bumper, office chair components. So in this application, we're looking at parts in a box, so in a shipping box, and we're detecting their presence, counting them, and then we also color classify them. So we determine that they're, all the parts that are there, should be there, are present, count, and then we verify that they're the right color in sequence. Hog rings, this Wes being in seating in the past knows that.
Wow, that's awesome.
Yeah, there's nothing that can sense hog rings right now.
That's amazing.
Yeah, and this is actually on a overhead on an assembly machine. So if I scroll through these pictures, you'll kind of see that the operator's working in this area. So we run this one in a continuous scan. So it's out of their way, and they're doing a lot of fastening and other operations while they're doing the hog ringing or along with doing hog ringing. So we just continuously scan, and when we see that there's 5 hog rings, then we send a signal to the PLC that it's okay to remove the part. Welds, we do mechanical welds. So sensing, pits, burnouts, things like that in welds. Window seals. Yeah, go ahead.
Do you think you could measure in continuous flow?
It depends how fast it is. Our systems aren't real fast.
Okay.
Because it's the AI based. So
yeah.
The solution for cycle time is to just inspect multiple parts at once. So in this case, we're inspecting 8 of these door seals at the same time. Mm-hmm. So when you got, fast production, but you guys are making bread, is that?
We're making bread, yeah. The thing I'm most curious, what do you think your processing time is?
It's about 4 seconds for high resolution image from start of taking picture to analyze. That's multiple parts. So like this, what you're seeing on the screen, we sense these different foam pieces, these clips, the end of the part in 4 seconds across 8 parts. So
how high wind from the part will it sense more? Because we're doing basically 120 or better loads per minute. But what I'm thinking here, Matt, low. Well, what I'm thinking, we're going to talk for a second here, Mike. So
yeah, no problem.
So we measure chain stretch. Bread cooker. Can we start watching the bread cooker? What's happening? So, if we could give it in, I could be open for something processing time and get the other. What I'm thinking here, Mike, is we have a lot of chains and conveyors and cooling racks and things like that. And one of our biggest failure modes is when those start to stretch, they cause all kinds of problems.
Yep.
So I'm wondering, okay, we snapshot every X seconds and we just measure those things.
Yeah, that's definitely an application that I'm not showing here, but I haven't done it, but it's definitely discussed it with Hormel, who's, food processing. One of their biggest issues is that the whole system breaks down on jam ups of pallets.
Yep.
So one of the applications that we had discussed is just looking for the jam up condition. So equipment monitoring is definitely a valid solution for this.
Yeah. Okay, cool. Let's roll through. How good are you at picking up print?
At print?
Yeah.
Good. Yeah, we can do OCR for sure.
Yeah.
Yeah.
That's awesome. I'm thinking for products that things like that.
Yeah, so I'm not sure if I included a picture in this group of pictures, but yeah, here we go. This one, we're picking up these labels.
Oh, you sure? Okay.
So really, here we're just verifying that label's present. We could read it probably if the camera was in the right position. This is just a general check It's like a 2D barcode followed by some text. So wood grain is another one. So we have a handheld unit where you can hold it against wood grain. So that's like a close-up picture of a piece of wood. This is a steel case project. And you kind of see like what resolution we can achieve if we're really close to the part. Different colors of wood, and wood grain's unique because you got wood of similar hues and colors. And traditional cameras will kind of just do the color thing. We actually teach it to sense the patterns in the grains of different types of wood. I got lots of examples of these. Metal. Yeah, there's a lot of applications for wood. Yep.
In terms of setup, how's this work? I mean, is this a standalone unit? You give us some instructions, we roll, and I need help to call, or do I purchase this for you?
Yeah, frequently we do the first install, but it's simple enough to set up. It takes about 15 minutes to set up. So it's not like Keyence or Cognex where you got to learn how to operate the software.
Yeah.
It's just menu driven. So no programming involved. Getting a camera to start taking pictures is like 15 minutes, literally. And then you just collect a number of pictures. Usually we request an online connection so we can go pull the pictures, do the training, and train the model. And then the way that this works is that we train the first version of the model to say 95% accuracy, and then the software itself will start to produce the labeling required to train more. So it automates the process of training more. So you go from 95, the first run, and then say 99.5 on the second run. And then from there, you're trying to reach perfection by just keep feeding it labeled images, which are produced by the machine at that point. So there's a human that verifies, but the machine is actually producing all the labels.
Yeah. So in a couple weeks.
Yep, in a couple weeks, you're going to have a near perfect machine. So the unit in general is about $6,500 with one camera. And then that's a 10 megapixel camera. As you add cameras, it's approximately $1,000 per camera. Additional cameras, and we can accept up to 4 cameras.
One unit can do 4 cameras?
Yeah, one unit can do 4 cameras. Yep.
Wow. Does that affect processing time at all?
Yeah, it'll affect processing time for sure because it runs sequential. So if you have a cycle time issue, you're better off just buying multiple boxes. And we can just daisy chain them together, reading off of the same trigger from the PLC to parallelize the picture taking.
Okay.
Yeah, so speed's an issue. I mean, the cost of the hardware is, I'd like to say really inexpensive, such that if you're just wanting to get more speed, you just buy more boxes.
Yeah.
And just to chime in what Mike was saying, I did, being hired on as sales, I've kind of done the market research on Cognex and Keyence, and we're about a fourth of the price of the hardware, that's for sure. And then our cameras are, from the resolution are great. Hey, quick question, Chuck and Wes, what would you guys use this for? Would it be quality control on the bread itself, or would it be of the machinery, of the monitoring of the machinery? What are you guys thinking that you would use?
I think Wes was thinking to start with monitoring a machine that we have in Google, and then eventually roll it into, product quality for sure. Yeah. I think we have opportunity in both. Yeah, for sure. The easier one for us would be to start some sort of machine monitoring. Just, keep with that's
That chain stretch. When the chain stretches and things get caught, does it actually break, or does it just toss things off the line?
it dance around things. That's the whole line now.
For an extended period of time?
Yes.
Okay, yeah, I think we can catch that. Throw an alarm when we see a certain condition, stop the line, for sure.
Well, it wouldn't be stop the line. It would just be notified at that point. Well, we can do whatever.
Yeah, you can just light a red light if that's the case. Yeah.
Yeah.
One thing about this our unit is that we have an onboard PLC.